Hi guys, it's your guy Olumide, and today we're gonna be solving another one of the most commonly asked tech interview question. It's the Sum Subarray. It's a DSA problem that is mostly asked by top tech companies including Google, Amazon, Netflix, Meta, Microsoft, and Apple. The problem statement states that find the number of subarrays in an integer array that sum to k, and we are giving an example integer array, so an input array, right, that will be given to us. And what this problem wants us to do is to find and to keep count of the number of subarray in an integer array that will sum up to k. And if you can see this particular subarray, so for an integer array, one could be a subarray. I mean, the very first element could be a subarray. Any sliced component of the integer array could be a subarray. So we say that 1, 2 is a subarray that sum up to 3, right? So this is one subarray that sum up to k, which is 3. Also, we also say that 0, 3, I mean that the range 0, 3 sums up to 3 again, because we have 1 plus 2 minus 1 plus 1 gives us 3, right? And similarly, this particular subarray 3, 4 gives us 3, sums up to 3 as well. So we have 3 subarray here in this particular input array that will sum up to 3. So that's why we have the output 3. So this is simply what the problem statement wants us to do. Given a particular integer or an integer array, we want to return the total number of times that a subarray sums up to k, or total number of subarray that sums up to k. A brute force approach to solving this problem is iterating through every possible subarray in the integer array that is given to us, and checking for each of the subarray if it sum up to k. Fine, it's gonna take O of n square, so it's gonna take a nested for loop to iterate through each and every possible subarray of the input integer norms. Like for this particular input integer 1, 2, minus 1, 1, 2, to iterate through every possible subarray in this integer is going to take O of n square. Why? Because for each of the value in the array, we have to iterate through the rest of the array one by one. So imagine for 1 now, we're going to iterate through starting from 2, then we're going to take 2 and minus 1, then we're going to take 2 minus 1 1, we're going to take 2 minus 1 1 2, then after doing that we're going to come back to 2 again, and for 2 also we're going to iterate through each and every of the remainder array. So that's what we mean by O of n square. But the thing that makes it even more inefficient is that for each of these array that we derive, imagine now for this particular one, we are going to iterate through the rest of the array, right? So starting from 2, we will have to perform a linear check, and by summing every element in this array to check if it sum up to 3. Imagine for this particular one, we are going to sum up 1 and 2 together to check if it sum up to 3. Fine, it do. What we're going to do again is that we're going to sum up 1, 2 and minus 1. So we're going to sum up 1, 2, minus 1 and 1, and each sum takes a linear time because we have to get to each element in the subarray, right? So that means that it's going to be taking us O of n raised to power 3, right? O of n raised to power 3 to solve this problem, so which is quite inefficient. So since we are working with subarray sums, we are dealing with sums of subarray, right? It will be worth considering how prefix sum can help us solve this problem. In my previous video on my YouTube channel, I mean the previous video, the one right to this one, I discussed that to find the sum between two range I and j in an integer array like this, in an array like this, to find the sum between a range I and j say I is 2 and j is 3, all we need to do is just to perform a lookup into our prefix sum. Prefix sum is actually an array, is a prefix sum array that consists of a running cumulative of this input array, right? So you can visit that my previous video to understand what I mean by this, and well, you can follow along with this video as well. It's really I'm gonna talk about what I mean by that as well. So the prefix sum of j minus prefix sum of I minus 1 is what gives us the sum between two range I and j by looking up the prefix sum. So when I say prefix sum, well, prefix sum is actually a running sum. Just like here now we have 1, so now the prefix sum will be 1, but right here it will be 1 plus 2, right here it will be 1 plus 2 minus 1, right here will be 1 plus 2 minus 1 plus 1, and right here will be 1 plus 2 minus 1 plus 1 plus 2, right? So that's prefix sum. So prefix sum of j minus prefix sum of I minus 1 is what gives us the sum of between two range of values I and j. So for subarray that start at the beginning of the array, actually the prefix sum is just prefix sum, and the formula is just prefix sum of j, right? So meaning that if I is 0, provided I is 0, and you want to find the sum between range 0 and 5, or range 0 and 4, or range 0 and any value, it's just gonna be the prefix sum of j. Now this means that what the problem wants us to do is that since we're already given the value k, I mean the value of the sum that we're looking for, definitely we just need a pair I and j such that prefix sum of j minus prefix sum of I minus 1 will be equals to that value, meaning that it's the sum of the range of value between I and j, between the subarray I and j, is actually equal to k. So you understand? So we just need the value I and j such that prefix sum of j minus prefix sum of I minus 1 is equals to k. That is if I is greater than 0. But in a situation whereby I is equals to 0, it's just simply this. In a situation whereby I equals to 0, we just need a value j. Since I is equals to 0, we just need an index j such that prefix sum of j is equals to k. So right, so this is what I mean right here. We just need a pair I and j such that prefix sum of j minus prefix sum of I minus 1 equals to k when I is greater than 0. Why? Because what the problem statement asks us to do is to find a sub array that sum up to which value that is contained in the sub array sums up to k. So, and now for any given sub array, we are definitely going to be having I and j, which represent the boundaries of the sub array. Now we just need the pair of I and j that makes up a sub array such that prefix sum of j minus prefix sum of I minus 1 equals to k, because in the situation by prefix sum of I of j minus prefix sum of I minus 1 equals to k, definitely that particular sub array sums up to k. So that is if I is greater than 0 though, but in the situation whereby I is equals to 0, we just need value of j such that prefix sum of j is equals to k. We can unify both cases for I is greater than 0 and I is equals to 0. We can unify both cases when we note that actually prefix sum of j equals to k is the same thing as prefix sum of j minus prefix sum of I minus 1 equals to k if this I minus 1 could be equals to 0, right? So if we have prefix sum of I minus 1 to be equals to 0, definitely prefix sum of j minus prefix sum of I minus 1 will be equals to k, since I minus 1 is equals to 0. So we just need to find a way to make prefix sum of I minus 1 to be 0 if I equals to 0, right? So because in a situation whereby I is equals to 0, we said prefix sum of j is just merely equals to k. But in a situation whereby I is not equals to 0, probably I is greater than 0, then prefix sum of j minus prefix sum of I minus 1 is equals to k. So to unify both states now, we just need a way of using the general formula, prefix sum of prefix sum of j minus prefix sum of I minus 1 equals to k. So but in a situation whereby I equals to 0, we just want this whole expression to be 0, so that way both cases are unified. But one minor issue is that imagine if prefix sum of I minus 1 is actually imagine if I is actually 0, right? Let's take I to be I to be 0. Yes, so in situation like that, we are going to be having a out of bound, out of index, a list index error, right? Because we'll be having prefix sum of -1, so which we don't want to have. So what we're going to be doing is that we're going to be appending 0 to the beginning of the prefix sum array, so that to make it possible for prefix sum of I minus 1 to be equals to 0 when I minus 1 equals to 0. So what I'm trying to say in essence is that in a situation whereby I equals to 1 and we are applying this formula, so in a situation whereby I equals to 0 and we are applying this formula, definitely I minus 1 will be -1, right? So which is invalid. So what we want to do is that I want to prepend 0 to the prefix sum, mean that prefix sum is going to have 0 initially, so which is going to represent the in the situation whereby I is equals to 0, so it's going to represent a situation whereby I equals to 0, so it can fall back on that 0 that we prepended to the prefix sum. So that way it will make it possible for prefix sum of I minus 1 to be equals to 0 when I minus 1 equals to 0, and in situation when I equals to 0, sorry, it's supposed to be I equals to 0. So and in situation like that, now we can easily have we can easily apply this formula. So because when I is equals to 0, we have prepended a 0 to this prefix sum array, so that it just gives us 0, and we can it is now unified. So whether I equals to 0 or I is not equals to 0, we can use this formula. So this is what I'm trying to talk about visually. This is our norms: 1 2 minus 1 1 2. This is the prefix sum, so which is a running sum. 1 plus 2 gives us 3, 3 plus -1 gives us 2, 2 plus 1 gives us 3, 3 plus 2 gives us 5. So this is the running sum. But now what we're going to be doing is that we're going to be prepending 0 to the beginning of the prefix sum. So once we prepend 0 to the beginning of the prefix sum, we just start our iteration from 1 from here. We'll start it from index 1, so that we can fall back at this 0 if I is equals to 0. So we'll be going into the code implementation now. So don't forget, what we want to do is simple, right? Let me just give you a quick explanation. What we want to do is that we are going to be leveraging on the prefix sum, so that don't forget, right from time I told you to solve this problem, a naive way to do it is to iterate through all possible subarray in this input array, right? And for each of these possible subarray, we want to sum up the value in each of these subarray, right? But that is going to be giving us a big O of n raised to power 3, right? Which we don't want because it is inefficient. So we can use a prefix sum array to remove to make it more efficient by avoiding having to iterate through each value in the subarray to sum it up. You understand? Fine. What we're going to be doing in the code implementation is that we are still considering every possible subarray, but now we don't necessarily need to sum it in linear time. We don't necessarily consider this particular subarray now. We don't necessarily need to do 1 plus 2 minus 1 plus 1. We already have a prefix sum array that will do that for us. All we just need to do is just to consider every possible subarray and allow the prefix sum array to do the sum for us in constant time. So that's simply what we want to do, and we'll be looking into that in the code implementation. Alright, let's dive into the code implementation now for the case sum subarray problem. We'll be defining the function